let's talk about piecewise functions a little bit more. So this is the second page on your notes sheet on the back, or the second page. So notice that these piecewise functions get a little bit more complicated because f of x equals these three functions over these three domains. So remember, this is the function, right? This is what the y equals, and this part is the domain. Okay, the points you can put in for x. Okay, let's go ahead and tackle this one. I'm going to use pink for this first function, negative x plus 5, if x is greater than or equal to, less than or equal to 0. So we'll make a chart, a table, x, and then the y is going to equal negative x plus 5. I'd like you to write it this way. I honestly think this is the easiest way to do piecewise functions. Sometimes piecewise functions confuse students, so I really like this way of doing it because I think it is easier. All right, we start with x is less than or equal to 0, so let's start with that point 0. And that says equal to negative 0 plus 5, so that y is equal to 5. Okay, and notice that's going to be a filled in dot when we graph it. All right, now we have to go less than 0, so let's go to negative 1. If we put in negative 1, that's a negative 1, so 1 plus 5, so that is 6. Let's just do another smaller point just to make sure we have a good graph of it. This is a line, right? Just x, first degree. It's a linear. Let's see. Negative 2, so that's 2, plus 5 is 7. Okay, let's graph this part. So we have 0, comma 5. And that's a filled in dot there. And then we have negative 1, comma 6 and negative 2, comma 7. Okay. And so that's just a line heading off that way because it just goes on forever, less than or equal to 0. All right, let's do the second part in blue. Okay, that part is square root of x. So we can do x and then y equals the square root of x. And notice we have to go from 0 to 4. So we can just do the points 0 and 4. That's fine, especially if we know what the square root graph looks like. Or maybe it's this way, I can't tell which way the video will show. If you put in the square root, if you put 0 in the square root, that is 0 still. If you put 4 in the square root, you get 2. All right, so let's graph that. Now notice it says x is less than 0, so the 0, 0 is an open circle. And then the 4, 2 is less than or equal, so that is closed. And remember, the square root graph is that little sideways parabola, right? Just half of it. So there you go. All right, and then for our final graph, let's look at that in purple. And that is f of x equals negative 2. So that's a number, that's a constant. X is greater than 4. So let's say x, and then y equals negative 2. That's here. And the domain is x is greater than 4, so that's 4 and above. So if we start with 4, maybe we want to do 5 and 6 after that, just anything greater than 4. When we put in 4 to y equals negative 2, we get negative 2. When we put in 5, we get negative 2. 6, we get negative 2, etc. Okay, so to graph that, we go 4, comma negative 2. And then let's see, it says greater than, so that is an open circle. Which, notice that you have a closed circle and an open circle. Remember, vertical line test. That's how it has to be. Okay. At 5, you have a point at negative 2, and at 6, you have a point at negative 2, etc. It's just everything greater than 4. Okay, so there's a really cool looking piecewise function there made of 3 pieces. All right, let's do one more to make sure we got it. And maybe you can always pause the video, try to do this one yourself, and then just check it with my answer. I think that would be a great way to do this, right? Because we have seen quite a few together. So you should just pause right now and then check the answer here. Okay? And I'll go through the answer a little bit quicker. Okay, well, hopefully you did this problem and were successful. We will still just quickly go through it together. So here's x, y is equal to 3, and we have to go from -4, and then x is less than -4, so -5, -6, and then y is always 3. So our points are here at -4, 3, and here and here. It's just a horizontal line this way. Okay. Our second function is y equals 1/2 x minus 1. So, and that is only between -4 and 0. So I'm just going to do those 2 points. 1/2 times -4 is -2 minus 1. And then 0 times 1/2 is 0, minus 1 is -1. So we have the points -4, okay, -3 right there. Now, notice that I was going quickly and I did make a slight mistake on the 3 one. This should be an open circle, right? Because it just says, and I bet you had that on your paper and I didn't. I bet you were right. So, and you were probably trying to shout at me through the screen. So that should be an open circle there. And I, would, of course, would catch that when I was doing this next part, if I'm thinking as I go, which I almost just did it again. Okay. So I would rather leave that kind of thing in these videos instead of making them perfect, because I want you to see, like, this is how it really works. You know, you make a little mistake, but then you catch it later, you think about it a little bit more, and you correct it, and that's okay. All right, and then the final part is x squared plus 5, so I'll put that over here. Okay. So, and that says it's x is greater than or equal to 0. So we have to put in 0 first, and then we would get 5, and then I might want to put in 1. So that would be 6, and I might want to put in 2. 2 squared is 4 plus 5 is 9, and that's good enough. So 0, 5 is included. 1, 6, and 2, 9 gives me that parabola that I'm seeing on the third one. Okay, and once again, I have a piecewise function. Notice the domains actually don't overlap, even though they almost look like they do. They are 3 separate domains, 3 separate functions.